So we're going to talk about percents, and percents are actually very similar to proportions, which is what we just got done with. And a proportion was something like on the bottom here that I'm circling now. It's just saying that we've got two ratios or two fractions and they're equivalent to each other. So how I think of it is that if I take 90 divided by 100, that's going to give me an answer, and then whatever number goes here on top, when I divide that by 12, it's going to give me the same answer. So in this instance, when I write a proportion, I would be trying to figure out something I don't know. So what I'm really trying to do is I'm trying to figure out what number would I put in place of the x that when I divide it by 12 gives me the same decimal as when I take 90 divided by 100. Okay? And so that's helpful because a percent is just a proportion, really, because a percent tells me how much out of 100 I have. So, for instance, if I shoot free throws, and I say that I have a 25% free throw percentage, what I'm saying is that if I shot 100 free throws, I would make 25 of them. Okay? That's not a lot, but that's what that's saying, is that a percent tells you if you imagine you did 100 of that, or you 98% on a test, means that if it were out of 100 points, I would have gotten 98. The test may have actually only been out of 50 points, but if I had kept going at the rate I was doing it, I would have gotten 98. So that's what a percent is. So there's two ways that we can think of percents. We can think of it as a proportion. So in this example here, if I got a 90% on a 12-question test, I want to know how many questions did I get correct. Well, my proportion is 90 over 100, because a percent always tells me how much out of 100. So that's where the 90 over 100 comes from. It comes from 90%. And then that's equal to some number over 12. And I'm trying to figure out, well, what is that number? Okay. So how we would do this in examples is that we would look at problems like this next one, where I want to know, okay, what is my percent of free throws made if I made 7 out of 9 free throws? So this is a little bit different. I made 7. I shot a total of 9. I want to know, well, if I continued to shoot and make at the same rate, and I shot 100 free throws, how many would I make? So we remember that to solve proportions, I cross multiply and divide. So that means I'm going to multiply these two numbers and divide by 9. So to solve this, I'd go 7 times 100 divided by 9. And whatever I get for an answer there, that is my answer. That's my percentage. So 7 times 100, and then I'm going to divide that by 9. So I see that I shoot at, if I round this to a whole number, I'm shooting at 78%, which means that if I were to shoot 100 free throws, I would make 78 of them. Okay? Percentages we see all around. Percentages like coupons, tax is a percentage. How much money you make in your savings account, that's actually as a percentage. And all that's saying is that if you were to have $100 in your account and you have a 4% interest, that means you're going to get 4 out of $100 added on. Okay, so that's kind of what a percent is. So we can set up proportions to do that, or we could actually use equations. So we're going to jump ahead a little bit here to some examples. And another thing we can use is an equation, and that's this here, where a percent, if this is representing my proportion, a percent is equal to a part divided by a whole. And that's the most helpful way to think about any percent problem, is look at the numbers, figure out what's the part, what's the whole that I'm talking about, and then know that if I want to find my percent, I take part divided by whole. Okay? And whatever I get is going to give me a decimal And I have to know that in order to go from decimal to percentage, I have to understand that a decimal can be written as a fraction. So if I just round to the second decimal place, that's the hundredths place. So then I can write that as 22 over 100. And while we saw before that a percent just tells me how much out of 100. Okay. So let's look at some examples here. And these are some other ways we might use this. So in this case, my example problem is, well, what number is 22% of 45? So in every single percent problem, I'm trying to find, okay, what am I looking for? And then what do I know? So in this case, what number is 22% of 45? Well, I'll tell you that the word of usually in whatever number is associated with that is usually talking about the whole amount. So 45 is the big number. And I want to know, well, what percentage or what number is 22% of that? So if I wanted to know what number is 100%, that would be 45. So I'm not asked for 100, I'm asked for less than 100. I'm asked for 22%. So I can think about that and know that my number is going to be less than 45. And in fact, if I know that 50% is like half, well, then that means that the number I'm looking for in this case is actually going to be less than half of that number. Less than half of 45. Okay. So how I would solve it is, okay, I'm wanting to find the part, that's the what number here, and the percentage is always easy to recognize because it's always signified by a percent sign, or usually signified by a percent sign. And then, like I said, the word of clues me into what's the whole amount that I'm talking about. So then it's just a matter of plugging in what I know. Well, if my percent is 22, I'm going to plug that in, and I'm always going to use the decimal form of percent. So I wrote 0.22 because that's the same thing as 22%, or 22 out of 100. And then my whole was 45, so then I plug that into my equation. So my equation, if I want to know the part, I take percent times the whole. And so I find that 22% of 45 is actually the number 9.9. Okay. But in every single one of these, I'm always trying to identify what's part, what's whole, and what's the percentage. Well, let's look at this in terms of tax and discounts. Okay, so bear with me a second here. So here we're looking at, for each problem, we want to know, or we're really asked to find, okay, what is the number, what's the sales tax in this case? And actually, what's her final bill? So I'm going to look at these numbers, and remembering my equations, that percent is equal to part over whole. Okay, or part is equal to percent times whole. And these are called the percent equations, and these are just things that we kind of need to remember. Those are the two main ones that we will use. Or we can think of it as a proportion, which we said my percentage is how much out of 100, and that's equal to part divided by whole. Now notice that's really saying the same thing as this first one here. So we can use either one. I'll do this one using both of them so you can see. So I'm going to use, first time, I will use red. So what is the whole amount? Well, we're told Miss Acton spent $205.60 at Target. If the sales tax is 6%, what is her final bill? Well, percent is always easy to recognize. So it's 6%. 6%, if I'm using the percent equation I need as a decimal, that's going to be 6 out of 100, which is the same thing as 0.06. To go from percent into decimal, I just find the decimal point where it is right here and move it twice to the left. So it becomes 0.06. Alright, then what's the other number here? This is $205 at 60 cents. Well, if I read this note up above, it says that sales tax and discounts are considered parts. So this $205.60 is not the sales tax, so this is my whole amount. Okay, so that means if I'm looking for the sales tax, that's what I'm trying to find. So I'm going to put that as a variable. I don't know that. Okay, so I'm going to use the percent equation here. So I'm going to pick the percent equation that has the thing I'm looking for by itself. So that means I'm going to choose the second one. So I'm going to write out this equation. Part is equal to my percentage as a decimal times the whole amount. Part, I don't know what my part is, and that's really my sales tax that I'm looking for. Percentage, I'm told, is 6%, so I'm going to write that as a decimal, 0.06. And that gets multiplied by the whole amount, which was $205.60. Okay. So now I just use my mathematical powers, or a calculator, and do that math. What's 0.06 times 205.6? $12, and since we're dealing with money, I'm going to round to the second decimal place. So we're going to round that to $12.34. So that means that there's $12.34 of tax. So that's the part that I was looking for. Okay, if I were to do this as a proportion, we'll do that in blue, I would do the same type of thing. My percent, now in a proportion, I can just leave it as the number it is up here. So I'm just going to write 6 over 100 is equal to, what's the part? Well, I don't know that, so that's my missing variable. And what's the whole amount? Well, that's the $205.60. So now to find what the part is, I cross multiply. So that means I take $205.60 times 6, and I divide by 100. And when I do that in my calculator, just to even prove it to you, 205.6 times 6, divided by 100. Look at that. It's the same answer we had before, $12.34. Okay, now if I look at the question, this is a little bit tricky, but the question is, what was her final bill? Well, if you think about it, what happens if you figure out, if you know you pay $1 in tax, does that add on to your, is that all you pay? Or does it add on to your bill? Or does it take away? Well, we know that tax adds on to my cost. So if she spent $205.60 and there was $12.34 in tax, then her total bill is just what I get when I add them together. And this is like what you'll be doing on your project. $205.60 plus $12.34 to find that she pays a total of $217.94. I hope I did that math right. Okay. So that's how we use percentages. We can think of them as proportions, or I can think of them as percentage equations like this. But either way, I need to know what's the percent amount, and or what's the part, and or what's the whole. But I'm always looking for these three things.